Welcome, ladies and gentlemen, to the second part of lesson 1.2. Today we are going to be getting into the two-step equations. Just as a reminder, remember whenever you're watching these videos, you can use them by looking for the time stamps, right? The timestamps that are in the comment section below, or the description rather, and you can get to rate whatever example you want, and that's how we'll do the videos all the time. So use these to your advantage that way. All right, without any further ado and wasting any of your time, let's get right into the second half of this lesson. So as a review, remember our order of operations, right? This is when we're simplifying expressions. This is not for equations, right? This is not for solving equations. This is simplifying expressions. For example, if I have 2 and then in parentheses I have x minus 6 squared, right? This is an order of operations problem where I would have to first do the parentheses and do the x minus 6. Let's say I didn't know, let's say instead of x, let's just turn it into an 8 or whatever. I would have to compute 8 minus 6 first in parentheses. That would give me 2 times 2, and then that's squared, a whole lot of 2's here. Then I would have to do the exponents next to get 4, and then 2 times 4 would be the last thing that I would do. Remember, that is for evaluating expressions, simplifying expressions, and it is not for solving. That's what we've learned in the beginning, right? In last class, we talked about solving one-step equations. What we talked about was undoing what is happening to x, right? So for example, if I give you something like 2x equals 12, we would say, what happens to x? Right? We wrote our forward step, and we would say it would be multiply by 2. And then we were at a solving step, and that solving step was undo this, right? And that was divide by 2. And then I had another column over here. I'm kind of out of space. And then we'd actually do that work, right? And we would look here to this column and say, oh, what do I have to do? I have to divide by 2. So we took 2x equals 12, and we divided both sides by 2, and we found out that, oh, x is equal to 6, right? Well, the problem is that idea of undoing only works when you have one step to undo. Because what if you have more than one step? Like, what if it said 3 plus 2x equals 12? Well, now we have to think about what's happening to x, but now there's more than one thing, right? There's multiplication and there's addition. So that's what we're going to work on today. How do I know how to do this when I have more than one step? So when solving equations, we also use PEMDAS, but in a different order. Solving requires us to work backwards and undo. So we're still undoing everything. Now we're working in reverse order, okay? If you're ever stuck or confused on where to start, sometimes the easiest way to figure out how to solve an equation is first by evaluating it, thinking about what's happening to the variable. You can even substitute a number if you want to. And then we work backwards, undoing each forward step you did. So what we really think about is the order of operations in reverse, right? And so we had that thing that said reverse and undo. That is our solving technique. So we take the order of operations and we stand them on their head. We're like, okay, first we undo addition and subtraction. Second, and then addition and subtraction is down here. Let me do this quickly. First, we undo addition and subtraction, right? Second, we undo multiplication and division, then we undo exponents, and by the time we're done with all that, parentheses are gone, okay? And then when we're undoing that stuff, obviously we're doing the inverse order. So let's see this in action, and this is really going to be a bunch of examples as we work this on out. So maybe you only need to watch a few of these, maybe you need to watch a bunch. It's up to you until you feel confident, right? So always writing the original equation, we got our 2x plus 9 is equal to 33. And it's asking what our forward steps are. What happened to x, right? And so now we have to think about our order of operations. If x was, say, 3, right? Well, we would have to multiply it first and then add 9. So that's the order in which I'm going to do that. I would say multiply by 2 for, I think I said 3 before. I meant to say 2. Multiply by 2. And I wrote 3. My bad. multiply by 2. That would be the first thing to do. Second thing to do would be to add 9. All right. Now, we are going to reverse those steps and undo them. So now I'm going to take the last one and make it the first thing I undo, which means I'm going to, instead of adding 9, I'm going to subtract 9. And then the second step becomes, or the first step becomes the second step. I'm going to undo multiplication by dividing by 2. And so again, all we did was identify what we would normally do in the order of operations. And we said, well, we'd multiply by 2, and then we would add 9. And then we reversed that order and undid the things we said we would do. Okay? And that's how we came up with this list. Now, the cool thing about this is that it's literally instructions that you have to follow. So we're going to write the equation 2x plus 9 is equal to 33. And now we're just going to follow instructions. So the first thing I have to do is subtract 9. And again, I got sides of the equation. Whatever I do to one side, I have to do to the other. And 9 minus 9 leaves me with 0, or just 2x. And that is now equal to 24. And then I've checked off that step. Now I'm going to do the next step. Step 2 is to undo multiplication by dividing. Divide by 2. Whatever I do to one side, do to the other. And that leaves me with x is equal to 12. And this is what we would expect to see on your independent practice when you guys submit your pictures. Next example. Okay, so we got 37 is equal to 4x. So again, original equation, 37 equals 4x plus 7. Now, the equal sign's like on the other side. That makes no difference. We still can ask those questions. Again, what is going to happen to x here? I'm going to first multiply by 4. According to order of operations, multiplication comes before addition. I would then add 7. And then we reverse those steps. Now this becomes the first solving step. And we undo those things. So I now, instead of adding 7, I'm going to subtract 7. And then I never put multiply by 4. Then I'm going to undo multiplication by 4 by dividing by 4. And then I'll rewrite that equation out. 37 is equal to 4x plus 7. And I'll undo those things. So I'm going to follow my directions. First, I'm going to subtract 7, size of the equation. 37 minus 7 is 30. That leaves me with 4x. Now, you're probably thinking to yourself, Mr. Vesbach, that does not go any evenly. And that's fine. We can get a fractional answer. No big deal. I'm still going to follow my instructions. I'm going to divide by 4. Whatever I do to one side, I do to the other. And I have 30 over 4 is equal to x. Now, I can simplify this fraction. I notice they're both divisible by 2. So 30 divided by 2 is 15. And 4 divided by 2 is 2. My real answer, my most simplified answer, and this is what we would expect to see in an assessment, is the simplified fraction 15 over 2. All right, next example. So this one's a little bit different because we have a fraction here, right? But really a fraction just means we're dividing. That's all that's really happening. So I got x, and I'll just say it, divided by negative 6. That's what it really is. Minus 11 is equal to negative 5. All right, so again, what's happening to x? What are our solving steps? So the first thing that's happening is right here, and that is divide by negative 6. After I divide by negative 6, what am I doing? I am subtracting 11. And now again, I will reverse that order and undo each step. So now instead of subtracting 11, I'm going to add 11. And instead of dividing by negative 6, I'm going to multiply by negative 6. In writing the equation again, we always start by doing that. X divided by negative 6 is equal to minus 11. Oh, I'd better just erase that. Start over. Minus 11, my bad, equals negative 5. There are my sides of my equation. And I'm going to follow my instructions. Step 1, add 11. Add 11 to each side. That leaves me with x divided by negative 6 is equal to 6. Now I have to multiply both sides by negative 6. So I will do that. Multiply by negative 6. Multiply by negative 6. Now I will say one thing here. Some students look at this and they're like, oh, look, it's a negative, it's a number divided by a number, and that really cancels out. And that, you can think of it that way and not get anything wrong. But the correct way to think about that is that negative 6 divided by negative 6 is really 1. So it's really 1x. That's how the x gets left behind. But we never really write the 1 in front of the variable. So I just wanted to give you a way to think about that, because that's how you should think about it. That's the correct way. So now x is equal to, now I just simplify this other side, negative 36. Okay. Next example. Same deal here. I'm going to move my little screen. It's like, there's no good place to put it. I guess I'll put it there. That works, I guess. All right. So original equation, 158 equals 27 minus 13x. So what are the 4 steps? I'm going to change this to add the opposite. Just it helps me keep track of signs as I go through problems. I highly recommend you do the same thing. 4 steps. What's happening to x? What's happening to x is being first multiplied by negative 13. So I'll write that down. Multiply by negative 13. And after I multiply by negative 13, in simplifying, I would add 27. So add 27. Again, I reverse those steps and undo. So that means instead of adding 27, I'm going to subtract 27. And then instead of multiplying by negative 13, I'm going to divide by negative 13. And then I will follow those instructions. So the equation is 158 is equal to 27 plus negative 13 or minus 13. Get my little equation sides going here. And I'll follow my instructions. So first step, subtract 27 from both sides. That leaves me with 131 is equal to, forgot my x here, negative 13x. And next step is to divide by negative 13. Divide by negative 13. And again, these don't divide, and that's fine. We can still get fractional answers. So my answer is 131 over negative 13 is equal to x, and that's fine. All right, next example, and that's the last one I think we're going to cover here. And that's example 11. So original equation, 2x over negative 5 minus 11 is equal to negative 5. All right, what's happening to x? Now, this is actually, you can think of this equation 2 ways. So if we think about what's happening to x, if it's written this way with a large fraction bar, you're more likely to think of this as, well, x is being multiplied by 2 and then divided by negative 5, okay? And that's true. That's not an incorrect way of thinking. However, I want you to consider this. 2x over 5 is exactly the same as saying 2/5 times x. Okay? And here's how you can prove that to yourself. You have to know how to multiply fractions, and multiplying by fractions means that we take the numerator times the numerator and the denominator times the denominator. So if I have x is equal to the same thing as like x over 1, right? So if I do that and turn this into x over 1, and then I go ahead and multiply fractions, well, guess what I end up with? 2 times x is 2x, and 5 times 1 is 5, right? So we ended up right where we started. And if we think of this, though, as this 2x over 5 as 2/5 x, we can actually simplify this a little bit faster. So I'll probably take you through both versions here. So let's work with this version first, and then I'll take you through the other versions. Right? So what are our forward steps, right? So what's happening to x? Well, first I would multiply by 2. Then I would divide by negative 5. And then lastly, I would subtract 11. So again, I have to undo all those things. So my last simplifying step becomes my first solving step when I reverse the order and undo what's happening. So I'm undoing subtraction by first adding 11. This says add, geez, I can't write. Let's try that again. Add 11. Do that first. Then I'm going to undo division by multiplying by -5. And then I would undo multiplication by dividing by 2. All right. So as we go through this, I have that equation, 2x over -5 minus 11 is equal to -5. So checking out the steps here. First thing I got to do is add 11 to both sides. So here's my equation line, and I'm going to knock this out. So plus 11 plus 11. That gives me 2x divided by -5 is equal to 6. Second thing I got to accomplish is the multiply by the -5. I got to get this out of the denominator. So I'm going to do that. Times -5 times -5. And same thing as before, right? The -5 divided by -5 is really 1. And the 1 times 2x gives me what I'm looking for of 2x. And again, if you want to say it cancels out, it's not necessarily the best thinking, but effectively, it's not correct. It's not incorrect. That gives me -30 over here. Then the last step here, the third step, is actually divide by 2. So what we end up with is x is equal to -15, and that is the final answer. Now, I do want to show how you can do this in a faster way in 2 steps by thinking of this as a fraction, okay? So if I were to take that same problem and instead of having the 2x over -5, if I would have instead thought of that as 2 over, and the whole thing can be negative, doesn't matter. -5 down here or up here or out front, doesn't make a difference. -2/5 x minus 11 equals -5. So what are my solving steps? Or I'm sorry, what are my simplifying steps, forward steps? My forward steps are still to subtract 11. But now my forward steps are multiplying by this fraction, right? So step 1 would be subtract 11. Step 2 is to multiply by a fraction, which is 2 over -5. And that's it. Those are my only solving steps, which means, or forward step, which means I'm only going to have 2 solving steps. My solving steps look like undoing this. So I'm going to multiply by 2/5. Now that should be divide by 2 over -5, but it's a fraction, right? So we never divide fractions. Instead, we're going to, hopefully you should finish this sentence for me, we're going to multiply by the reciprocal. So that is what's going to save us the work. We're going to multiply by the reciprocal. And that's our first solving step. After we oh, I screwed up the solving steps here. This should be step 1, multiply by 2/5. This should be step 2. I got too excited in showing you this. My bad. So step 1 would be to multiply by 2/5, right? Step 2 in the forward steps would be to subtract 11. And then this would be the second solving step, and this would be the first solving step of adding 11. Anyhow, so if my first solving step is to add 11, just like before, I'm just going to take care of that. Add 11 plus 11. I'm still going to get my 6 on the other side. Over and over, get a 5x equal to 6. And now I'm going to do this multiplying by the reciprocal, which is the same as separately multiplying by -5 and dividing by 2, which is what we did before. So the reciprocal of 2 over -5 is -5 over 2. Right? I will turn this into a fraction so I can make that multiplication easier. This whole thing here is going to give me just x because the numerator gives me -10. The denominator gives me -10, and -10 divided by -10 is 1x, which is what we're looking for. And now I just simplify this, right? 6 times -5 is -30. Times 1 is 2, which gives me exactly where I had before, and I just got to simplify that to -15. All right, so independent practice is going to be to finish your worksheet for 1.2, and it's just the rest of the two-step equations. Make sure that you go ahead and do the Schoology check and also upload a picture, both things, if you've only been doing one of those. Take care and have a great day. Peace.